All right, guys. Welcome to our last lesson of P8. P8 is a fun topic, I think, because it is proper physics, and this is definitely very based on A-level content. So nice stuff, but yeah, a little bit tricky, especially when we're not together. But I have supported you hopefully with the solution video that I've put up that will hopefully make it bit more easier to manage in our absence and our separation from each other. All right, so let's find out what it means to resolve forces or resolution of a force. So last time we talked about the parallelogram of force, and that's where we were able to take two different vectors and add them together to find a new vector, or the resultant, the sum of those vectors. Today what we're going to do, it's going to look very similar, but in fact what we're doing is we're going to be taking one force vector, and we are going to be resolving it, pulling it apart into horizontal components and vertical components. And this is the first step in an analysis that we often do in mechanics that allows us to look at what's happening horizontally, what's happening vertically, because the vertical never talks to the horizontal never talks to the vertical. So if we can strip these out and separate these, we can actually solve really very complicated problems much more simply. So a force can be resolved, or say broken down into two component parts at right angles to each other. So that's an important definition. So again, this is why this is in a yellow box, straight from the spec, really quite important. So these components combine together to have a single effect. And again, I always want you to be using your common sense with these problems. So if you imagine you're being pulled up and kind of diagonally, you know there's going to have to be something that's lifting you up and also something that is moving you to the left, or in this case, the right. It's hard to tell from your perspective. But so always think about, well, if I'm going upward, there's something that has to be pointing me upward. Oh, but I'm shifting this direction, so I'm going to actually be moving diagonally. So these are going to be the two different forces that we can think about that work together to make a diagonal force, if the way you want to think about it in that way. All right, so there's two different ways we can do this. One is using a scale drawing, and the other is using trig, so some maths. So the scale drawing is really useful when the forces are not at right angle. If it's not like well, all these will always be at right angles. But I guess it's more for a parallelogram force, so let's scrap that. It's usually easier to use trig, but I am going to show you how to use a scale drawing because technically you do not need to apply trig for GCSE problems. All right, so for example, if you had a 11.2 Newton force, which is acting diagonally in this case, then we can resolve that into its different forces. So what we would do is we would actually take a 11.2 newtons and actually use our ruler and actually draw it out, and then we can use it to find out what is the horizontal and what is the vertical. Now this is really hard for me just telling you right now, but I have shown you how to do this in the tutorial. So the bronze task is actually just going through finding out what these resultants are, and then you'll see in the silver, which is a little bit add-on for that, which I would like all of you to be kind of pushing on into the silver task, is how to measure using a scale to find out what those horizontal and vertical components are. However, actually, trigonometry using SOHCAHTOA is easier. Now, when I show you this, you might be thinking, "Oh, doesn't look easier at all." But in fact, oh, sorry. Let me show you an example of a scale drawing here. Anyway, so if we have, in this case, we have this trolley's being pulled. Kind of imagine a little kid walking along and pulling this little car behind them, and they'll be kind of pulling that string up, but they'll be pulling it forward as well. And if we think about each one of these little boxes here being 1 Newton right and left and 1 Newton up and down, then we can see that the 5 Newton force is actually broken up into 3 boxes vertically and 4 boxes horizontally. So that means that we have a vertical component of 3 Newtons and a horizontal component of 4 Newtons. So that's showing how we can use a scale. So again, kind of like think about it like presenting this onto graph paper. That would give us our scale drawing. This is actually a 3, 4, 5 triangle, which is a good thing to remember. Sometimes makes maths really easy. You think, oh, it's a 3, 4, 5 triangle. It's always true. If it has a 3 and a 4, its hypotenuse will always be 5. All right, so this is the one I was saying. Don't panic too much when you see this. Again, this is straight from your maths. So SOHCAHTOA. SOHCAHTOA I still use, and my A-level students, and at university you will use SOHCAHTOA. So the SO stands for sine is equal to the opposite divided by the hypotenuse. So now we need to make sure that we recognize, well, what is the opposite, what is the adjacent, what is the hypotenuse? So that's what that little triangle there on the right shows us. So the hypotenuse is the diagonal. So whenever we're looking at our vector, that hypotenuse is going to be our main vector, the diagonal vector. The opposite is going to be our vertical component, and the adjacent is going to be our horizontal component. Again, we would always be using the same context here. So if I'm trying to find out what the opposite is, and I know what the vector is, if I know what the hypotenuse is, then I can use sine. So sine of the theta there is going to be equal to the opposite divided by the hypotenuse. Again, I've shown an example of this in the gold task on the solution video, so please have a look at that. Again, you can fast forward if you're going straight onto the gold task. Again, cosine ka, cosine of the theta is equal to your adjacent over your hypotenuse. Again, so we would use that for looking for our horizontal components. The horizontal component is going to be our hypotenuse times by the cosine of theta. So you can see there down at the bottom, it's kind of summarized of how we use SOHCAHTOA. Actually, we won't be using TOA actually in this lesson, but that's if you only are looking at the tangent and the adjacent. So looking at only the component vectors. All right, so this is applied oftentimes in physics as kind of down a slope. And now the reason I want to mention this again, I don't want any of you to be panicking, but you imagine that you have a some sort of like gradient or some sort of slope there. And you imagine if that's my surface and I have something that's perpendicular to it, that when I lift that up, my arm, you can see, is moving away by the same amount as the slope is moving up. So that's a good way to kind of get your head in the trying to find those similar triangles whenever you're finding something down a slope, which is kind of a classic physics problem. So that means that if we're looking for a force component down the slope, it is going to be the opposite. So we're going to be using sine, and hopefully you can see that in this picture here. If you can't right away, don't worry about it. I mean, I think all of the learning that I have always done, I've kind of done it after the lesson when I have a chance to digest it. So that's why the learning tasks are so important, is it allows you a chance to kind of digest these. Again, so for example, we might be using a problem like this where we're looking at pulling a box up a slope, and that parallel component is going to be equal to a resistive force as you're pulling a box up the slope, and that the perpendicular component is what we know as the normal force. So we're going to get to know these, again, if you're taking A level, we'll get to know these really, really well. This is pretty much as far as we go, though, for GCSE. All right, guys, this is the fun part. So I have your tasks all on Show My Homework. I want you to, again, most of them, the silver builds off the bronze and the gold builds off the silver. And then I do have one platinum task here, which is kind of fun. Again, the platinum is purely optional, or the extension task. Please make sure, though, that you do bronze, silver, gold beforehand. Again, you do not have to do all of the tasks. Please choose the one that is appropriate for your goals. And I will be on Show My Homework if you have any questions. And in fact, I'm going to stop recording now because I appreciate that some of you might actually have questions you don't want to ask whilst I am recording.